Okay, so we're talking about geometric probability for these ones, which we want to keep in mind. Probability is going to be a ratio, a fraction, and we're talking about the thing that we want over the total possible outcome. So if we're looking at the random probability of landing on CD, let's just look at it. There's CD, that's a distance of 4, and then the whole range, what's called our sample space, the whole place you could land is going to be 10. And so the probability is just the length of CD over the total length, and that becomes 4/10 or 2/5 as we go through it. The next one is somewhat similar. We have to take our time though with where we start. And so we have a bus that arrives every 25 minutes, and we want to know if she has to wait no more than 10 minutes. So no more than 10 minutes means 10 or less. Okay, so 7 works, 6, 5, 4, anything in there. So if we were to redraw this, right, I have A and B, that's the total time range, that's 25 minutes, 0 minutes to 25 minutes, and then 10 minutes means that she's 10 minutes from the bus coming, and the bus coming is B, right? If she shows up 1 minute after point A, she's got to wait 24 minutes to get there. So if we go backwards from B, that's 10 minutes. So 10 minutes are okay. Anything in there, she's going to wait less than 10. And then that brings us down to 15 minutes. But it's really a length, right? So it becomes 10 minutes. That's this area, this length in here that works over the whole length, and the whole length is 25. So we get 2/5 again. On the next one, we're dealing with a target. And our target is we have colors here, and then over the whole thing, our whole area, which is 12 by 12 or 144. So you can see they have it for 144. And they did the blue region, and they got, with a radius of 1, they had pi over 144, about 2.2%. If we double that, so double the radius, instead of 1, it's 2, and we do the same area. The probability of blue is the area of blue over the total area. And so area is pi r squared for a circle. That becomes 4 pi over 144, or around 0.087. And that, if we look back up here, compared to 0.022, is about 4 times as much. So it went up by, when we double it, we got a factor of 4 larger in terms of area and probability. And then if we make it 3 times as big, our radius is 3. And if we do the same thing, the probability of blue is the area of that circle up here, so pi r squared, 3 squared over pi, which is 9 pi over 144, or 0.19. If we look at that compared to the 0.22, that gives us something that's about 9 times the size, or probability of that happening.